In this video, we're going to recap what you guys practiced yesterday in your activity and practice some more with circumference application. So just to recap what you guys practiced yesterday, let's go over our definitions and our vocabulary. So we know what the radius, we have the variable r that we're going to be using is the distance from the center. So this is our radius. And I want to make sure that you guys are comfortable with the variable, and it's a small letter r. So then we have a diameter. Diameter is distance across the circle. And it does take, and I'm just going to abbreviate here, it does take two radius measurements. So this is the first one, and this is the second one. And altogether, they're going to make diameter. So it takes two radius values to make diameter. This relationship, guys, is really important because we have to know how these two are related. So what I just said is diameter is two measures of radius. So hopefully you guys are remembering when you have a number and a variable next to each other, that means it's multiplication. If we are given diameter, and we need to find the radius, we would say, oh, diameter divided by 2 will give me radius. All right, so next one is circumference. And so just like before, you know, radius and radius, this is one measure of diameter. And it takes 3 measures of diameter, guys and girls. Again, it's approximate, so circumference is distance around the circle. Okay, so this is rotation around the circle. Okay, and it's going to be this circumference. We have 2 formulas for circumference. It's all going to be depending on what you guys are given to work with. So you have diameter measure or radius measure. We can use them both to find circumference. So if we have diameter, we would say pi times diameter. The value of pi is approximately 3.14. So when we do some rounding, this is where that 3 comes from. 3 measures of diameter. Or if we have a radius measure, we would write it as 2 pi r, because we have the relationship that takes 2 radius to have a measure of diameter. Let's put this to work, guys. So in this particular note, your questions are in a table format to make sure that we can organize our workflow and be comfortable with these examples. So if we have a radius of 10 and then we have a diameter of 20, what is the relationship? It is 10 times 2. Radius of 9, I can use multiplication in this format, will give us diameter of 18 centimeters. So what happens, guys, if you already have diameter and you need to fill in this value of radius? What would you do? Here we were finding the greater value, so we were multiplying, but since we have a greater value, we will be dividing. And that gives us 32 divided by 2 will give us 16 centimeters for the radius. All right, so now let's take a look at diameter and circumference relationship. So again, just you can refer back to our notes earlier. So we have diameter 14. We know we have to multiply by pi. So just a reminder, pi is 3.14. Super important value for us. Okay. 14 times 3.14 will give us 43 and 96 hundredths. In the second example, guys, we already have a circumference. So what would happen? We don't have the formula, so let's go ahead and write it down. We need diameter, we have circumference. So diameter would be calculated by dividing circumference by pi. So all I'm doing, guys, is I am reversing this formula from earlier. To find circumference, to find that great distance, I multiply diameter times pi. To find a smaller value of diameter, I will divide circumference by pi. So 12 and 96/56 would be divided by 3 and 1400. A little short on space, guys, but this is your division. Okay, that gives me 4 centimeters. All right, and our last example. So when we have, I'm going to just make it a little bit more bold. We have 26 centimeters as our diameter. We need to find circumference. So 26 times 3.1400, our pi. So it's our diameter times pi. That's what we're doing, guys, in all of these, or dividing circumference divided by pi. So this is our process that we were utilizing. And that will give us 81 and 64 centimeters. So you guys are noticing when we're working with the actual pi value, we are always going to have decimal values. You guys need to make sure that you're following rounding instructions. If they're simply ask you to approximate, we are then going to be using the value of 3. So the approximation, guys, would be in our last set of examples right here. To approximate means to estimate. So for our estimation, we are going to, I'm going to go ahead and kind of highlight this. So when we are approximating, we are given a little bit of flexibility, of freedom. So let's just do this. We're going to say pi is about 3, and that will help us with our process. So we have circumference, we need to find diameter. So how would you go from 48 to 16? This is our division process, So from here we would have 48 divided by 3 will give us 16. So we have a approximate circumference of 36. We have diameter of 12. What is the relationship, guys? Hope you see in the pattern here. Yes, it is division by 3. Division by 3. Okay. In our last scenario, you guys are seeing that you are given the diameter and we are asked to approximate the value of circumference. So this is going to be a reverse process. So this is your diameter times pi. Okay, so it's 5 times 3 since we are approximating, and that will give us 15 centimeters circumference. Okay. So this in this little box, guys, it is a summary of what we have been applying during this practice. So circumference, C, is equal to pi times its diameter, or pi times twice the radius. So I'm going to go ahead and write it closer here, or about 3. So these are the formulas that were referred to in an early example. Let's go ahead and write down one more. What if we have a radius? So we have a circumference application for diameter and radius. So if we have circumference and we find diameter, we'll divide circumference by pi. If we have to find radius, we will take circumference and divide by 2 pi. So this is the reverse of this application formula.